Let's talk about how we can recreate a vector if we know its components. If you look at the table here, I'm giving you the x and y components of 4 different vectors. 2 of them are vectors of displacement. You can tell that by the units, meters and kilometers, that would be displacement. Meters per second would be velocity, and meters per second squared is acceleration. Because you know that those 3 are vectors. You're about to learn about forces next. That's also a vector, so they have magnitude and direction. Now, magnitude is how strong, how fast, how far the force or distance, or rather displacement or speed or acceleration, if we're talking meters per second squared, how big that quantity is. That's magnitude. If you look at a vector here, for example, 4 and 6 runs 4 meters in the positive direction, meaning to the right or east, if you want to think about it that way, and then 6 meters up. So vertically and horizontally. Horizontally, it's a positive 4 to the right, and vertically, it's a positive 6, meaning up. So if I were to recreate those, here they are. We have 4 to the right, 6 up. Notice that I'm making them just dotted lines because those are not the actual vectors. Those are just components. So here's the actual vector, and that is what we're about to find. This is a hypotenuse and a right triangle. The right angle is right here between the 2 components. I can write this as 4 meters and 6 meters right here. Pointing northeast, but since we're figuring out the actual vector, we need to find this angle as well. Now, what do I do to figure out the magnitude? I use the Pythagorean theorem, right? That is a root of 16 plus 36. That gives me 7.2 meters. And then, before I answer in full, I need to also figure out the angle. Now, since this is tangent, I'm going to technically, if I know 7.2, I can figure out sine, cosine. So inverse tangent of 6 over 4. That's what you're going to put into your calculator. Make sure that your calculator is in degrees. I will remind you that on the test and on the quiz. It will be 56 degrees. If I look at my 2 components, 4 meters positive, that's to the right, 6 meters positive, that's up. Then my vector itself is 7.2 meters at 56 degrees to the horizontal. To calculate it, again, I'm using Pythagorean theorem. So I'm going to plug in 16 as the 4 squared, plus 49 is the 7 squared, 8.1 meters. When I square root that, I need to find this angle. It's going to be opposite over adjacent. So it's going to be inverse tangent of 4 over 7. And when you plug that into your calculator, 4 over 7, I get 29.7, 8.1 meters per second at 30 degrees, and it's going to be northwest. In the next vector, I see that my x component is positive, but my y component is negative, so it's pointing east for 3, and then it's pointing south for 2. That angle is going to be southeast. I do not plug in -2. Inverse tangent, this is opposite, so 2 over 3. That's going to be 34 degrees, 33.69 rounded up, so 34 degrees, and it's going to be southeast. And then actual vector, the magnitude of it is going to be the root of 9 plus 4, so the root of 13, which is 3.6, and this is kilometers, because again, this is our displacement. So my answer for number 3 will be 3.6 kilometers, and it's going to be at 34 degrees southeast, which is right here. And then the last example, everything is negative. This is a vector of acceleration because I see meters per second squared. I would do tangent of opposite is 7 to 8 southwest. And then the actual, you have 64 plus 49. The magnitude of this vector is going to be, you're welcome to do 10.6 or just 11 meters per second squared at 41 degrees southwest. All right, that's how you do it. If you have components, doodle them, use Pythagorean theorem for the magnitude, and then inverse tangent, opposite over adjacent for direction. That's how you do it.